All right, welcome to the deep dive. Today we're gonna try and tackle some coordinate geometry.
Oh, very nice.
Yeah. So we've got some sources here that deal with I guess like the spot where algebra and geometry like meet up.
Right. Yeah, yeah.
And it seems like a pretty foundational topic, right?
Yeah, yeah.
But I think it's actually a lot more powerful than maybe we initially give it credit for.
I think that's right.
So yeah, I mean, we're talking about, the X and Y axes and plotting points, and this stuff is used in all sorts of fields, like physics, engineering, navigation, even seismology and art.
Yeah, yeah.
And I think it's just remarkable how, like, just by assigning some numbers to geometric ideas, it allows us to unlock all sorts of secrets, you know?
Yeah, I think what's really interesting is that it provided a bridge between algebra and geometry, so you can understand geometry through algebra and vice versa.
Right.
And that opened up all sorts of, you know, new mathematical discoveries and practical applications, and they're still with us today.
Yeah, for sure. And in this deep dive, drawing on some of these great resources, we're really zeroing in on two, I guess, key concepts: the distance formula and the section formula.
Yes.
And our goal here isn't really just to like, memorize these formulas, but to really like understand like where they come from
Right. Right.
and how to apply them. So,
Mm.
yeah, just really think of this as equipping yourself with the skills to navigate the coordinate plane with like real understanding.
Exactly. Yeah.
Okay, so let's get into it.
All right.
Let's start with the idea of finding the distance between 2 points.
Okay.
So, if you've got 2 points that are like lined up on the x-axis,
Mm-hmm.
say like point A at 4, 0,
Right.
and B at 6, 0.
Okay.
Figuring out the distance is pretty straightforward
Yeah,
to
you
get
see,
at.
yeah.
It's just the difference in their x-coordinates.
Yeah.
So 6 minus 4
Huh?
gives us a distance of 2,
Exactly. Yeah.
and you can see that on a graph, just that horizontal separation.
Mm-hmm. And the same logic applies vertically.
Right.
So if you had point C at 0, 3 and D at 0, 8,
Okay.
the distance is just the difference in the y coordinates,
Yeah.
8 minus 3, which is 5.
5, exactly.
Yeah.
Okay. So that's pretty easy, but what if our points are not, aligned with either axis?
Right.
So, let's say we've got point A at 4, 0, on the x-axis,
Hmm.
and then point C at 0, 3 on the y-axis.
Yeah.
How do we find like the distance, like the straight line distance between those 2 points?
Right. So in that case, you can't just subtract the coordinates.
Right.
You have to use the Pythagorean theorem.
Ah,
Yeah.
okay.
So if you imagine those 2 points
Mm-hmm.
and you connect them with a line, what you've done is you've created the hypotenuse of a right triangle.
Okay.
So the other two sides of that triangle are along the x and y axes, and they have length 4 and 3.
Oh, I see. Yeah.
Yeah. So if you remember, a squared plus b squared equals c squared.
Right.
You have 4 squared plus 3 squared
Yeah.
equals ac squared. Let's call the distance ac,
Okay.
and that gives you 16 plus 9 equals 25.
Right.
And then if you take the square root of both sides, you get ac equals 5.
5. Okay.
And actually, that's a 3, 4, 5 triangle.
Right. Okay.
Yeah.
Yeah. I see that.
Yeah. So that idea that can be extended to any 2 points.
Okay.
So let's say you had P at 4, 6,
Okay.
and Q at 6, 8,
Okay.
and you wanted to find the distance between those two.
Right.
So again, you can imagine a right triangle. So if you draw a horizontal line from P and a vertical line from Q, they're going to intersect at a point.
Yep.
Let's call that point R.
Okay.
And R is going to have coordinates 6.
6, 6. Okay.
Right, because horizontally it's the same as Q.
Right.
And vertically it's the same as P.
Got it.
Yeah. So the horizontal leg of that triangle, PR,
Right.
has length 6 minus 4, which is 2.
2.
And the vertical leg, QR, has length 8 minus 6, which is also 2.
Also 2. Right.
Yeah. So now the The line segment between P and Q, PQ,
Ugh.
is the hypotenuse
Okay.
of that right triangle PQR. So you
Right.
can apply the Pythagorean theorem again.
Okay.
So you have PQ squared equals PR squared plus QR squared,
Yep.
which is 2 squared plus 2 squared,
Uh-huh.
which is 4 plus 4, which is 8. 8.
Right.
Yeah. So the distance PQ is the square root of 8, which is 2 root 2.
2 root 2. Okay.
Yeah, so it's what's neat here is that the coordinates, the numbers themselves,
Right.
give you the lengths that you
Yeah.
need
Yeah.
for this geometric theorem.
Okay, so what about if the points are in different quadrants?
Right now.
So maybe they have some negative coordinates.
Right.
Does the same principle still apply?
Yes, absolutely. So let's say you had P at 6, 4,
Okay.
and Q at -5 and -3.
Okay.
Again, you can visualize this.
Yeah.
You can still form a right triangle.
Yep.
So imagine drawing a vertical line down from P
Okay.
and a vertical line up from Q,
Mm-hmm.
and then a horizontal line connecting those two.
Right.
Yeah. So the horizontal distance is the difference in the x-coordinates,
Yep.
which is 6 minus -5,
Which is 11.
which is 11, right?
Yep.
And then the vertical distance is the difference in the a-coordinates, which is 4 minus -3, which is 7.
7. Okay.
Yeah, so those two numbers, 11 and 7, are the lengths of the legs of the right triangle.
Right.
And so, again, you can apply the Pythagorean theorem.
Yep.
So you have PQ squared equals 11 squared plus 7 squared,
Mm-hmm.
which is 121 plus 49, which is 170.
Okay.
So the distance PQ is the square root of 170.
Square root of 170.
Yeah. So you see, even with negative coordinates, you can still apply the same geometric idea.
Yeah. Yeah. Okay, so I'm seeing a pattern here.
Mm-hmm.
It seems like we're consistently, finding the horizontal and vertical differences,
Right.
and then just applying the Pythagorean theorem.
Yes.
So is there a way to generalize that,
There is, yeah.
like into a formula?
Right. Yeah.
So that works for any 2 points.
Exactly. That's exactly where the distance formula comes from.
Okay.
So if you follow that logic,
Yeah.
the horizontal distance between 2 points, P and Q,
Mm-hmm.
is going to be the absolute value of x2 minus x1. And the vertical distance is going to be the absolute value of y2 minus y1.
Right. Right. Mm-hmm.
So when you apply the Pythagorean theorem, you get PQ squared equals the quantity x2 minus x1 squared
Okay.
plus the quantity y2 minus y1 squared.
Okay.
And then you take the square root of both sides.
Yep.
And you get PQ equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared.
Okay.
And that's the distance formula.
Right. Okay.
Yeah.
And that's it, huh?
That's it, yeah.
Okay.
So it looks complicated, but it's really just the Pythagorean theorem
Yeah.
expressed in terms of coordinates.
Right.
Yeah.
Okay. And so the squaring there, that takes care of any negative signs
Exactly.
from the subtraction.
Yeah,
And then the square root gives us the actual distance.
exactly.
And it doesn't matter which order we subtract it.
That's right, yeah.
Because we're squaring it.
Yeah, exactly.
Yeah. Okay, that makes sense. And is there a special case for the distance from a point to the origin?
Yes, there is.
Okay.
So the distance of any point P with coordinates x, y from the origin,
Mm-hmm.
which has coordinates 0, 0,
Right.
is going to be OP, let's call the distance OP,
Okay.
is going to be the square root of x squared plus y squared.
Okay.
Yeah. So that's a useful formula to remember.
Right. So it's just like the regular distance formula, but you just assume the other point is 0, 0.
Exactly. Yeah.
Okay, that makes sense. So let's look at an example.
Okay.
From one of our sources.
All right.
So example 1 asks if the points 3, 2, -2, -3, and 2, 3 form a triangle,
Okay.
and if so, what type?
Okay.
So how would we go about doing that?
Right. So the first thing we need to do is label those points.
Okay.
So let's call them P, Q, and R.
Okay.
So P is 3, 2.
Mhm.
Q is -2, -3.
Yep.
And R is 2, 3.
Okay.
So to see if they form a triangle, we need to find the lengths of the sides
Right.
using the distance formula.
Okay. So we need to find PQ, QR, and PR.
Exactly.
Okay.
Yeah.
So for PQ, we would have the square root of -2 minus 3 squared
Mm-hmm.
plus -3 minus 2 squared,
Yes.
which is the square root of -5 squared plus -5 squared,
Mm-hmm.
which is the square root of 25 plus 25,
Right.
which is the square root of 50,
Okay.
which is like 7.07.
7.07. Okay.
Okay, great. And then for QR,
Okay.
we would have the square root of 2 minus -2 squared plus 3 minus -3 squared,
Right.
which is the square root of 4 squared plus 6 squared,
Yeah.
which is the square root of 16 plus 36, which is the square root of 52,
Okay.
which is like 7.21.
7.21.
Okay. And then finally for PR, we would have the square root of 2 minus 3 squared
Mm-hmm.
plus 3 minus 2 squared,
Right.
which is the square root of -1 squared plus 1 squared,
Right.
which is the square root of 1 plus 1, which is the square root of 2,
Right.
which is like 1.41.
1.41. Okay.
So now we have the lengths of all three sides.
Mm-hmm.
So to figure out if they actually form a triangle,
Right.
we need to use the triangle inequality theorem,
Right.
which says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side.
Right.
So let's check that out. So PQ plus PR,
Sure.
7.07 plus 1.41 is 8.48, which is greater than QR, which is 7.21.
Okay.
So that's good. And then PQ plus QR,
Yeah.
7.07 plus 7.21 is 14.28,
Okay.
which is greater than PR, which is 1.41.
Okay.
And then QR plus PR,
Okay.
7.21 plus 1.41 is 8.62,
Okay.
which is greater than PQ, which is 7.07. Okay, so it looks like they do form a triangle.
I do. Yeah.
Okay, so now we need to figure out what type of triangle it is.
Right.
So we can do that by looking at the squares of the side lengths,
Right.
and seeing if they if they satisfy the Pythagorean theorem.
Right.
So PQ squared is 50,
Okay.
PR squared is 2,
Okay.
and QR squared is 52.
Right.
And hey, look at that.
Yeah.
PQ squared plus PR squared, 50 plus 2 is 52,
Right.
which is equal to QR squared.
Exactly. Yeah.
So so that tells us that the triangle must have a right angle opposite the side QR.
Right.
So triangle PQR is a right triangle.
Exactly.
It's yeah, it's just amazing how like this algebraic tool, like the distance formula, it just like it allows us to like classify geometric shapes
Absolutely.
so precisely.
Yeah. The distance formula isn't just about finding distances. It's
Right.
about analyzing geometric figures
Yeah.
and understanding their properties.
Right.
Yeah.
Okay, cool. So so key takeaway number 1.
Okay.
The distance formula is really just the Pythagorean theorem expressed in the language of coordinates.
Yes.
And it gives us a really powerful way to measure the distance between any 2 points.
Exactly. Yeah.
Yeah. Okay. So so let's move on to the section formula,
Okay.
which our sources describe as a way to find the coordinates of a point that divides a line segment
Right.
in a given ratio.
Exactly. Yeah. So
Right.
so like let's say you have a line segment, you want to divide it in half.
Right.
You could use the section formula to find the coordinates of the midpoint,
Okay.
or you could divide it into thirds,
Yeah.
or any ratio you like.
Right. Right. And so this formula, it gives us a way to like precisely locate those points. Like that we're dividing the segment.
Exactly. Okay.
So the source starts with a really like interesting real world example of a like telephone company
Mm-hmm.
that wants to place a relay tower between two towns.
Okay.
So let's say the towns are A and B,
All right.
and they want to put the tower at point P,
Okay.
and they want the distance from P to B
Okay.
to be twice the distance from A to P.
Right.
So the ratio is 1 to 2.
1 to 2. Right.
Okay. And they give the coordinates of B relative to A as 36, 15.
Okay.
So they're kind of considering A to be the origin.
Right.
So the question is, how do we find the coordinates of P?
Right. And that's exactly what the section formula is for.
Okay.
Yeah. So, in general, the section formula is a way to find the coordinates of a point
Mm-hmm.
that divides a line segment
Yep.
internally
Right.
in a certain ratio.
Okay.
So let's say we have 2 points, A and B,
Okay.
and the coordinates of A are x1, y1,
Mm-hmm.
and the coordinates of B are x2, y2.
Okay.
and we want to find a point P.
Yep.
That divides the segment AB.
Mm-hmm.
Internally, the ratio M1 to M2.
M1 to M2, okay.
Yeah, so the section formula tells us that the coordinates of P are going to be M1 times X2 plus M2 times X1 over M1 plus M2.
Okay.
And then M1 times Y2 plus M2 times Y1 over M1 plus M2.
Right, right.
Yeah. So that's the formula.
Okay.
So how did we get that formula?
Yeah, can you walk us through that that derivation?
Certainly, yeah. So imagine drawing perpendicular lines from A, P, and B to the x-axis.
Okay.
So they meet the x-axis at points R, S, and T, respectively.
Okay.
And then draw lines AQ and PC parallel to the x-axis,
Okay.
where Q is on PS and C is on BT.
Okay.
So what you've done is you've created two triangles, triangle PPQ and triangle BPC.
Okay.
And those two triangles are similar.
Similar. Okay.
Yeah, because the lines AR, PS, and BT are all parallel.
Right.
And AQ and PC are parallel to the x-axis.
Okay.
So similar triangles have proportional sides.
Right. So we have PA over BP equals AQ over PC equals PQ over BC.
Okay.
And now we can express the lengths of those segments in terms of the coordinates.
Right.
So AQ is the horizontal distance between A and P,
Okay.
which is X minus X1.
Okay.
And PC is the horizontal distance between P and B,
Right.
which is X2 minus X.
Okay.
And PQ is the vertical distance between A and P, which is Y minus Y1.
Okay.
And BC is the vertical distance between P and B,
Right.
which is Y2 minus Y.
Okay.
So if the ratio of PA to BP is M1 to M2,
Okay.
then we can set up the proportions.
Right.
M1 over M2 equals X minus X, 1 over X2 minus X.
Okay.
And M1 over M2 equals Y minus Y, 1 over Y2 minus Y.
Right. Okay.
So we have two equations and two unknowns,
Right.
X and Y.
Okay.
So we can solve those equations for X and Y.
Yeah.
And that gives us the section formula.
Section formula. Okay.
Yeah. So it's all based on similar triangles.
Yes, it is.
Okay. And then what about the midpoint?
Right.
Is there like a special case of the section formula for the midpoint?
Yes, there is. So the midpoint is the point that divides a segment.
Right.
In the ratio 1 to 1.
1 to 1.
So M1 is 1 and M2 is 1.
Right.
So if you plug those values into the section formula, you get X equals X1 plus X2 over 2.
Okay.
And Y equals Y1 plus Y2 over 2.
Right. Oh.
So that's the midpoint formula.
Okay.
Yeah. So it's just the average of the X coordinates and the average of the Y coordinate.
Right. It's very, very intuitive.
It is, yeah.
Okay, cool. So let's do some examples.
All right.
Example 6 asks us to find the coordinates of the point.
Okay.
That divides the line segment joining 4, -3, and 8, 5
Okay.
in the ratio 3 to 1
Okay.
internally.
All right.
So here we have, X1, Y1 is 4, -3. X2, Y2 is 8, 5.
Right.
And M1 to M2 is 3 to 1.
Okay.
So we can just plug those values into the section formula.
Exactly, yeah.
Okay, so for the X coordinate, we would have 3 times 8 plus 1 times 4
Right.
over 3 plus 1,
Right.
which is 24 plus 4 over 4,
Okay.
which is 28 over 4, which is 7.
Is any, yeah.
Okay, and then for the coordinate, we would have 3 times 5 plus 1 times -3
Right.
over 3 plus 1,
Right.
which is 15 minus 3 over 4,
Okay.
which is 12 over 4, which is 3.
3, yeah.
Okay, so the point is 7, 3.
Exactly.
Okay, great. So now example 7 kind of flips the script, right?
Right.
It asks, in what ratio does the point -4, 6?
Okay.
Divide the line segment joining -6, 10, and 3, -8.
Okay. Wow.
So here we know the coordinates of the dividing point and the endpoints, but we need to find the ratio.
Right.
So how do we approach that?
So we can use the section formula
Okay.
and set up equations. So let's say the ratio is M1 to M2.
M1 to M2.
Yeah. So then we have -4 equals M1 times 3
Okay.
plus M2 times -6
Right.
over M1 plus M2.
Okay.
And then 6 equals M1 times -8 plus M2 times 10
Right.
over M1 plus M2.
Okay, so we have two equations.
Yep.
And we have two unknowns.
Right.
M1 and M2.
Yeah.
So we can solve for the ratio M1 to M2.
Exactly.
Okay, so let's take the x coordinate equation.
Okay.
So -4 times the quantity M1 plus M2 equals 3M1 minus 6 meter 2.
Right.
So that simplifies to Negative 4m1 minus 4m2
Hmm.
equals 3m1 minus 6 meter 2.
Right.
And then if we move the m1 terms to one side
Okay.
and the m2 terms to the other side.
We get 2m2 equals 7m1.
Okay.
So m1 over m2 is 2 over 7.
2 over 7.
So the ratio is 2 to 7.
Exactly.
Okay. And the source also mentioned that we could use k to 1 as the ratio,
Yeah, right.
which might simplify the algebra a little bit.
We might, yeah.
Okay. And then example 8 talks about trisection,
Okay.
which is dividing a line segment into 3 equal parts.
Right.
So we need to find the coordinates of the points of trisect of the segment joining 2, -2, and -7, 4.
Okay.
So if a line segment is trisected, that means there's 2 points
Right.
that divide it into 3 equal parts.
Right.
So let's